Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, the topic today is not very complicated. It is very easy for you as you are very well aware of acid based concepts since your school time. Now, uh, we will discuss at the first about history and development because in ancient times people were well aware about uh, sour taste or soapy effect of some compounds. So for your thirst I have given some uh, history about. I have discussed that how developed, Boyle. He was very successful in summarizing and reporting, uh, or he was having a scientific approach to define that acids, they have sour taste, they are corrosive, they change the color of certain vegetable dyes, and when they are combined with alkalis they lose their acidity. And for bases, he reported that they have slippery uh, feeling when touched, and they also change the color of litmus, and when they lose their alkalinity when they are combined with the acids. You can go through uh, this detailed document I have given, because three famous concepts are discussed in detail, that what are Arrhenius acids and what are Arrhenius bases. When any acid, it is when it is put in water, H positive ions are released, liberated, donated, and when there is a base like sodium hydroxide, when it is put in water, it is dissociated into sodium ions, cations, or hydroxyl anions. But there are many acids which don't have H positive, like aluminum trichloride, AlCl3, but it is an acid, and ammonia, it doesn't have any hydroxyl group. So here, and there are many compounds which don't give reactions in water. Then what will be the definition of acid or base there? So simply Arrhenius is that any compound which gives off hydrogen H positive ion in water are acids, and which give or lose or remove, or hydroxyls are removed in water, they are bases. So due to these limitations, different scientists, they came forward, and two scientists living in two different countries, Bronsted and another scientist Lowery, they put forth at the same time concepts about acid and base. So they were successful in discussing amphoteric behavior, what are conjugate bases, what are conjugate acids, what is solvation, how it stabilizes solvation, how it stabilizes acidity or basicity. So uh, in just winding up, because detailed I have given you So long discussion is not required. As you will go through the whole document, you will be able to know yourself. The examples I have given you, the definitions I have given you separately, that what is Arrhenius acid, what is Arrhenius base, what are examples in these two acid bases, and how Bronsted and Lowry they were successful in giving a good development made by them in almost same time in two different places. So Arrhenius H positive in water will be an acid, OH negative in water will be a base. Bronsted sees or gives Bronsted-Lowry, they give this definition on the basis of proton, that if any compound which is donor or loser of proton is an acid, and any compound which accepts proton, that is a base. So both acid or base are defined on the basis of proton. If anything which is donor, proton donor, that will be an acid, and which is proton acceptor, that will be base. Now, as I discussed that ammonia or pyridine, these are bases. There is no hydroxyl group, and they could be defined on the basis of their lone pair availability. So, on this basis, anything which has tendency to take electron, like AlCl3, it takes electrons and becomes AlCl4 minus. It is Lewis acid. And anything which has tendency, so acids are electron acceptors. According to Lewis theory, acids are electron acceptors and bases are electron donors. Arrhenius, now comparing three. Arrhenius tells H positive liberated in water, OH negative liberated in water are bases, H positive liberated in water are acids. Bronsted-Lowry on the basis of proton. Anything which is proton donor or loser is an acid. Anything which is proton acceptor is base. And Lewis, he tells that on the basis of electrons, electron acceptors, acids are electron acceptors, acids, and those compounds which are electron donors are bases. Okay, in Bronsted-Lowry theory, uh, when acids they lose their proton, like hydrochloric acid, it gives off H positive plus chloride. Chloride is known as conjugate base. HCl is an acid. HCl is an acid. On giving off proton, Cl negative will be known as conjugate base. If acid is strong, its conjugate base will be weak. Now, another term to be introduced for your concept is solvation. Uh, I have given you example of solvation means solvent, and the most important international solvent is water. When an ionic compound dissolves in water, like sodium hydroxide. Sodium hydroxide is a base. Sodium hydroxide is dissociated in the water, and why there is no possibility of when sodium hydroxide is dissociated in water into sodium plus ions and hydroxyl ions. But if sodium plus and OH negative, they again recombine. It means there will be no net reaction, because uh, a reactant is dividing into two products, and if both of these products are recombined, it means there is no net reaction. But what happens in the water? Sodium positive is solvated by water molecules, and OH is again solvated by water molecules. Sodium is positive and hydroxyl is negative. Sodium positive is solvated by oxygen terminal, which is negative. Lone pairs are present there. So O lone pairs, they solvate, they surround an A positive, from which side where oxygen is present, and hydroxyl negative is surrounded by H side of H. So these both are separated or far apart from each other. Now they cannot combine. Sodium positive cannot combine OH negative, and they will be quite far from each other, so there will be no chance of recombination. So there is no possibility of sodium hydroxide, and solvation stabilizes the ions. You can take many examples like HCl, other acids or bases, how water solvates those positive and negative terminals. If terminal is negative like OH negative, H will be surrounding that environment, and if terminal is positive like sodium, like potassium, so negative terminal of water from O side will surround that dissociated cation. So I hope you will be able to uh, define acid bases on the on in Arrhenius. According to Arrhenius concept, you will be able to define acid base on the basis of Bronsted-Lowry concept, and you can tell or explain the definition or concept of Lewis acid and base, and you know clearly about conjugate acid or conjugate base, what these are, and what is solvation, and how solvation stabilizes cations and anions, and it will help compounds or acids or bases stability. If solvent is good, meaning that it is solvating anion and cation, there will be no possibility to recombine, and that will be considered as good acid or good base. Like sodium hydroxide is a good base because it is solvated in the by the water molecules, and it will not recombine, and you will get hydroxyl anions as behaving as a base. So dear students, you are able to uh, go through. I have given many examples of silver and ammonia, between fluoride ion and boron trifluoride. These are behaving as an acid and as a base, and I have given you reaction of proton and water, because H positive ions, they are according to Lewis acid base definition, they are Lewis acids, and water is Lewis base. The reaction between the water molecule and the proton, it gives hydronium ion. You are very familiar with the concept of hydronium ion. If not, you can see the example, because the lone pair, it is giving, donating its available lone pair to proton, which has no electron at all. Proton is accepting electron, and water molecule is giving electron. So water is Lewis base, and proton is acting as an as a Lewis acid. Ammonia has lone pair and proton has vacant orbital. So ammonia can donate its lone pair to make a bond. It becomes, by giving lone pair, it becomes positive, and ammonium cation is formed, and silver has no electrons, it is positive. This complex is formed. Two ammonia molecules, they are reacting or combining with silver cation, and complex formation occurred. This is adduct form. So the adduct formed from the Lewis acid, silver positive, and the base, which are two molecules of ammonia. And boron is behaving as a Lewis acid, and fluoride anion is behaving as a base, Lewis base. So fluoride act as an electron pair donor, whereas BF3 acceptor of electron pair. Electron acceptor are acids, so BF3 boron trifluoride is an acid. The reaction between Lewis acid and Lewis base is resulting in the formation of adduct BF4 minus. So I hope this will, inshallah, clear your ambiguities or any confusion, or if some issues are there. If you are not able to understand, I have given um, I have tried to clarify your concepts and detailed definitions, explanation, examples, and an important topic about solvation. I have told you how solvolysis occurs and what are spectator ions. In water, uh, sodium hydroxide. So if HCl and sodium hydroxide, what happens? Water plus that chloride is present, and sodium from sodium hydroxide. Two water molecules are formed, and NaCl salt. So these are spectator ions. This example is also given. We can check, and some other important things are also discussed. And I hope, inshallah, you will understand. From exams point of view, I will the lecture after this one will be important from your exams point of view. So kindly have clear concepts solvation is important because in your upcoming lecture I will discuss factors stabilizing anion or cation leaving after proton or base, how what factors stabilize. For example, uh, there is an acid, it is liberating proton plus anion. So how solvent playing its part, how it is solvating positive and negative poles, and is delocalization or resonating structures are beneficial to stabilize the um, dissociated anions or cations, or what other factors, hybridization, or what factors are stabilizing cation and anions. So coming lecture will be beneficial for your these concepts. So try to clarify your concepts. So the coming lecture, which is important with respect to your exams, will be easy for you to understand. Okay, I pray that it becomes, may it be easier for you to understand. And if you have any questions, you're most welcome to ask. Thank you very much.